Hey guys, today we're going to be talking about arrays. Now, arrays is something really cool in coding. It's a coding concept that you're going to see is a little bit hard to understand at first, but once you understand it, it is going to be really useful. So let me just put you in context here. We want to create a game that contains a grid. Now, if I just take Unity for a second and I just show you what I mean really quickly, what I want to happen in this game is I want to have like data for every single little square we have. Right now our snake moves in, we could say meter, I guess. So it moves by 1 meter every single frame, every single 0.5 seconds. What I'd like to know is information on where he's going right now. So every single meter we end up going into a new tile, you could say. And I'd like to actually keep this tile inside some kind of information. So let's recap real quick. Let's just assume that our snake game is being played in that 10 by 10 grid. This is actually the Unity grid, and I'm just going to be using it for a visual purpose. So let's just say that our game is being played like that, and the snake, say, he starts here. On the first frame, he moves, well, on the first move, he moves here, then right, and until he actually gets a key from the user that says either up or down or left, then he's not going to move in any other direction. You know, he's moving one tile at a time. Now, what I want to keep here in memory, what I want to keep in terms of information, is what lies inside of every single one of those tiles. Now, in terms of the game logic, what I am going to do here is I'm going to be keeping every single of those tiles. I'm going to be keeping all of those inside of memory using a int per tile. Now, here's my actual logic that I came up with. So we have a tile, say this one up here, and if it's empty, then its int, its actually integer value, is going to equal 0. Now, if it has an apple inside of it, so the apple is the thing that you eat to become a bigger snake, if it has an apple, I'll say it's equal to -1. Now we have -1 for apple, we have 0 for nothing, which is, you know, that's easy to understand. Now, the logic I came up with is whenever I eat something, my snake gets bigger, and my snake is going to have like a size in the end, so say size 5. Now what I want to do with this logic is the last one, the very last fragment of that snake is going to be 1. The second last is going to be 2, then 3, then 4, then 5, if he has a length of 5. And every single move, I'm going to check all the grid, and I'm going to do a -1 on all the values if it's not -1 or 0. So if my value is 1, I actually put that on 0, and at the same time I'll delete it. If my value is 2, I'll just do a -1. So next frame, next move is going to be on 1, then the other next move is going to be deleted. And actually, I can use this logic to just keep on going like this until I get rid of all the little snake part that he left behind. So that's what I plan on doing. It's a little bit complicated, like I said right here, but the reason I wanted to introduce this context is because we need to use arrays for this. You could be like going the stupid way and just go up here, say int tile 00 is equal to 0, then int tile 0 or 01 is equal to 0, and just do that times 100 actually, because you got a 10 by 10 grid. That would be the stupid way to go about it. There is something else where you can keep multiple values of the same type, and it is called an array. Let me just show you how to write down an array, and then we'll get to actually trying to visualize what an array is. You can go like this, well, not private, sorry. You can go like the following. You type down the type of the information you want to keep in that array, in this case int, then you open up some square brackets, and then you give it a name. So I'll call this one grid is equal to a new int grid, and then you can give it a size, so say 10. Okay, so what this did is it kind of declared 10 different ints. So it kind of declared 10 different values that I can actually use. And the way I can access those values is like this. So right now, since they're all default ints, they're all equal to 0. If I want to get the very first value, I type in the name of my array, so grid in this case, then square brackets, and I just access it using the index we call. So if I want to access the first one, I have to type in 0, since index are 0 base. You're going to start at 0, go up to 9 in this case. The array has a length of 10, which means if you include 0, it has up to an index 9. If you go at 10, you're going to be looking for like a 11th object and it's going to crash. So if I want the first one, I just type it this way and I can actually get the int that is out of it. So debug.log grid 0 is going to tell me the very first value in the int. So in this case, 0. They're all on 0 right now, so we could be testing it out as much as we want. They're all on 0. Same thing if I want to go at the 6th value, actually, type in grid 5. In terms of visualizing this, in terms of just putting this like in drawings in your head, just have a look at this very first line. This is what our array looks like. It looks like the exact same thing as this over here. Imagine that the very first index, so the one I was accessing earlier using grid square bracket 0, is this one. So I actually drew on my screen a little bit, maybe you can understand it better that way. Every single of those tiles can be defined with the index. So if I want to access the data inside of this one, I have to say grid square bracket 9. If I want to access data inside of this one, grid square bracket 5. And it just keeps on going like that. And that is very cool for, say, a linear game. Say we're only like playing on a single line, but that's not what Snake is. Snake is actually played on a two-dimension grid, which makes things a little bit complicated here because we're going to be talking right away. And sorry about this, I'm just jumping from arrays to multidimensional arrays, which is quite a big gap to be honest, but we have to talk about multidimensional array in our case. So we just understood, at least we understood a little bit how the normal array works. So you just access using the square brackets, you go to the index you want, and you grab the int value in this case because it is a int array. Now, in this case, we have two dimensions. We have 10 in like this, and we also have 10 in y. And we can actually do that. We can actually do that in terms of code by putting a comma in between of those, just like this. You also have to give a size to your other axis. So in your case, right now it's a 10 by 10. If you wanted to make your game, your Snake game, say a 15 or a 20 by 10, so it would look like this instead of have this whole grid, you could say new int 2010. This way you would have 20 values on the x and also 10 values for every single x of those values. Let's actually go ahead and just try to access the very first index. The way we do this is quite simple. 0 in x and 0 in y. This is how you access the very first value. Let's have a look at the game now using this grid like we mentioned. We're back with the 10 by 10 grid. Let's say we want to access the one in the middle. Well, maybe not in the middle, but this one. To actually access it, you would have to count, or you know what, let's move our player here. To access this one, you would have to count how many x do you need. So right near 0, 1, 2, 3, 4. So 4 in x, we can write it down. And now in y, you do the exact same thing, but starting on the y-axis. So 0, 1, 2, 3, and 4. So to access the actual player's position right now, you would say grid at the index 4, 4. Because our grid is just full of value 0. There is nothing else. We're not keeping any information just yet, but we've created our grid. We just established our grid, and that's the very first step we need to take. So let's just assume that we understand this. Well, at least we have a very basic understanding of how it works. What we're going to be doing next is we're going to be replacing our snake a little bit, because this snake, you know, this is the head of the snake, and the head of the snake needs to have a position inside of the grid. You need to keep track of that position. So what I will be doing here is the following. We're going to go in our code. We're going to type in some information about our snake here. So we're going to call it snake length, which is also your score at the same time. So snake length, or let's just call it snake score. If the score is 5, that means the snake actually takes 5 space. So right now it's equal to 1. At the very beginning, we might make it bigger eventually, but right now let's just put it to 1 just so we can have a basic understanding of how this works. So snake score is equal to 1, and this is the value I'm going to be putting in the arrays every time I want to actually move. Some other information that would be really useful is to know where exactly is the snake right now in our grid. You know, we move it on the 3D on the 3D plane. We move it in the 3D world, But in terms of our 2D grid, we don't really know where he is at right now. So I'll create another int called snakex, which is going to equal 0, and another one called snakey, which is going to equal, let's just make it 4. So he starts exactly, if we go back here, 0, 1, 2, 3, 4. He starts exactly here. Or actually, I'm using the wrong grid. I should be actually moving around the center of the world, but on this side. So instead of being there, I'll be moving it up here, which gives me 0.5 and 5.5. Okay. Oh, sorry, 5.5 in Z. This is where my snake is going to start, because 0 in X means it's on this very axis, and then 4 means it's on 0, 1, 2, 3, and then 4. So exactly here. Now I'll leave my snake here, and every time he moves, I'll be just shifting it towards another array, so another index of that array. So let's go right inside of our start. When the game begins, let's tell the array, let's tell the actual grid where our snake is. We're going to go ahead and just say grid, add the index snakex and snakey, just like we've done earlier. We're just replacing the values, the hard-coded values, by actual int that we declare, is equal to the snake score. So wherever the snake is going to be equal to 1, which is going to just leave some trail of where the snake has been right now, because we're never really resetting that value afterward. We'll see about resetting it in a moment, but right now, if we press play, then even if we move this index right here, all the grid is equal to 0, but this index right here, this index is actually equal to 1. Now every time our snake moves, if you can just come back, every time he moves, what I'd like to do is we're going to start off by just taking its position, checking where he is in the grid, and we're going to turn that into the snake length. So all of this line would now be 1. So at this point, we need to interpret that vector3 direction. So turn direction, or actually add up direction to our snakex and snakey. And here's how I'm going to do it. I'm going to be using some simple condition here. Just like we've done in the past, we're going to go ahead and just say if direction dot x is equal to 1, which means if the actual direction we're going in x is equal to 1, that means we're going right. If it's equal to 1, I'm going to say snake x is plus plus. Simple as that. Now we're going to duplicate this a few times again. So let's take snake direction x and just copy it 3 times. So if the direction is -1, it means snake x minus minus. Now if direction dot y is 1, it means snake y is plus plus. If direction dot y is equal to -1, that means he's going down. So snake y minus minus. Did I make any mistake in this? I don't think so. We now have updated our snake x and snake y. Let's actually update our grid as well. So let's do grid snake x, and then snake y is going to equal snake length, or snake score, sorry. With this new logic, what happens is the following. So every single tile you see here is actually being set on 1, but at this point there is no more array, which means we get some errors and the game actually crash. It says the index is out of range. Now let me just explain to you what this error is, because you're going to be seeing it quite a lot when you start making games. So let's just have a look where exactly it pops. This is our very last tile in the grid. We have a 10 by 10 grid, so 0, 1, 2, 3, 4, 5, 10, okay, right here. And at this point, when we move over to this tile, we're now on the 11th x-axis, which in our array does not exist because it's an array of size 10. So when we reach that, it just simply crash. And well, I mean, we can't really go beyond that point. It means we have to either increment our array or just make sure he doesn't go that far, which we will in a moment. But as you can tell, we can't actually set values here, and it does cause problem. However, something that they just tell us is that this function was successful, so we were able to replace every single tiles by 1, because we were replacing all of those, and at the moment we try to replace this one, it doesn't exist. So we know that we're at least accessing all the other ones, which is cool. This is what we want. Now there is two things to do at this point. We have to make sure that it doesn't go beyond those points, so it doesn't go beyond 10. And we also have to make sure that wherever we were in the past goes back. Quit. And we have to make sure that wherever we were in the past is actually being reset to 0 because the snake is no longer there. So let's start by a simple one. Let's just limit the snake on both x and y axis. To do so, all I have to do is take that move function. Well, first I have to change that move function. Let's take that move function we've done and move it in between the snake plus plus here and also the grid assignation. Now by doing this, I actually calculate where my snake is going first, and then I'm going to have a condition here. If he goes out of bound, then we do something, and then we only move him if it's possible, and we only change the grid if it's also possible. Let's actually write down that function, not function, but that condition. It's a really simple condition. Check this out. So if snake x is equal to 10, or no, that's not going to work. If snake x is bigger than 9, because remember, we're 0 base. So you can actually reach 9, but if you go beyond 9, that means you're on index 10, which would mean the 11th object, because you're 0 base. So if you're on the 11th object, let's do a debug.log just to test this out. And we're going to say out of bound in x. Go back in the game, quickly test this out, and it should actually be called at the moment we reach here, and afterward it's going to keep being called non-stop. So out of bound x. So what we're going to be doing is, if you reach that out of bounds, well, first you lost. So I'm just going to be putting brackets on this. Sorry about this, I forgot to put my brackets on the if statement. Just a little note like that. If you only have like one line of code after an if statement, you don't actually need to put some scopes. You can leave it like that. But at the beginning, I recommend that you don't do this so much because you might forget about it, or you might just be lost in your statement. So let's say if snake is bigger than 9, well, first we lose. So let's say something like we lost. And if we don't lose, if we're not out of bounds in x, let's actually do the rest in the else statement. So if we're not out of bounds, if we're not out of bounds, let's just do our typical move functions. And if we are not out of bounds, we just keep on going with these statements. So this is going to give us some problem. Let's just go back in the game, try it out. And we just keep on moving, and at the moment we reach this side. Okay, so x is now equal to 10, which means we're on the 11th object. Let's not move. We're only doing what is inside of the if statement, which means we're going to say we lost. And we're not going to be running this because this is in the else statement. This has to be false for this to run, right? Now this is problematic because, say if we go down, then we end up getting the same error. We never really check. We check only this side. So if we reach this column, then we stop. However, we didn't check this one, we didn't check this one, and we surely didn't check the one at the very top here. And here's how we're going to be fixing this. We're going to be implementing multi-condition if statement. I've mentioned those a little bit earlier before, but it was not really clear, so let me just do that again really quickly. We have a if condition, and inside of that if condition, we have the possibility to say and statement or. So if snake is bigger than 9 and something else, or something else. If that is true, then we say we lost. What we need in this case is we need to say or. So if snake is bigger than 9, or snake is smaller than 0, or snake is bigger than 9 in y, or snake is bigger or actually lower than 0 in y, then we say we lost. So we need to add we need to add 3 different if statement. We could go ahead and just make copy this over 4 times, but our code is going to start looking really messy. So here is what we're going to be doing. We're going to be using the pipe sign, pipe sign, and that is the or statement. This way we can add another condition here. So if snake x, and now we've just covered both sides. Let's try this out. We're going on the right side. We already know this is working. Let's go on the left side. And then it says we lost. So we're covering both sides with that single if statement. Let's go ahead and do the y-axis as well. So or, snake y is bigger than 9, or snake y is smaller than 0. In this case, our player should not be able to move out of the bounds anymore. And now let's go down. We're crashing on down. Let's go up. And we're also crashing on up. And this is actually where I'm going to end today's episode, because in the next one we are going to be talking about for loops. We're going to be talking about loops in code. So another code concept that you have to understand before making games, or any software really. So we're going to be talking about that in the next episode. We still have one problem, like I mentioned. We still have the values. Right now it's invisible, but we still have all of those 1 values being set right here. So this whole line is set on 1 right now. We have to put that back on 0 every time we move. So we're going to be doing this in the next episode. Right now we're going to, like I said, we're going to end up here, and we are going to just call it a day. So guys, thank you so much for watching. Thanks so much for tuning in. I hope you learned something. I hope you liked the video, and if you did, please leave me a like. Really appreciate that. You can support the courses. You can support me personally using the Patreon page or the Facebook page. Just sharing the course around would be nice as well. So if you guys can do that to help me out, would be really grateful, and I will be seeing you guys in the next one. Cheers.